We want to use mesh current method to find the V out in this circuit as an example of illustration of the mesh current method. So this is a simple circuit. To do that, we just need to find the value of Ix because this dependent voltage source needs the value of Ix. In this case, Ix is simple. We can just write down one simple KVL here to figure out Ix. And to do that, we just see the uh, 4-volt voltage source is equal to the current that is flowing the two series resistor 5 ohm and 3 ohm. So it would be 8 ohm total. So it would be 8 times Ix. And then from here, we conclude that um, Ix is just 0.5 amp. Okay, so having that, then we can deal with these two loops here, these two mesh, and the simplest way we can deal with them is assume that there is a current I1 flowing through this um, loop or mesh, and assume that the current I2 is flowing through this one. And now our job is finding I1 and I2. For this loop here, we can write a simple KVL. So it will be, let's say KVL1, we have 10 volt is equal to, um, we have 2 ohm that I1 is flowing through, and then we have V out, which is 16 times I1 flowing through it, and minus I2 that is flowing counter I1. So that would be one equation. We have also KVL2 in this equation that we can write. So we have KVL2, um, which for that one we have V out, which is again 16 times I1 minus I2 um, is equal to 12 times I2 plus um, the value of this voltage that current I2 is flowing through it. So it would be 4 times Ix, and Ix is half an amp, so it would be 2 volt. Okay, so we have our 2 kVL, and then we can simplify these two equations further. So from here, we can say 10 is equal to 18 I1, and then we have minus 16 I2. And then from this one, we have 2 is equal to, that's the 2 here that I'm keeping, and then moving 12I2 to the other side. So I have 16I1, and then I have minus 16I2 minus 12I2, we have minus 28I2. So these are the two equations that I'm going to rely on, and I'm going to use Kramer law as simple as just saying that this are two equations, two unknown, and I can write simply in the form of I1 is just equal to determinant of 10 and 2, and then minus 16 and minus 28, divide by determinant of 18 and 16 and minus 16 and minus 28. So if you compute this, you will end up with minus 280 and then plus 32, so it would be minus 248. And in denominator, you will also find it's minus 28 times 18 plus 256, so it would be minus 248. So the answer is 1 amp. That's the current for I1. We don't need to write down Kramer law for the I2, but if you're interested to see how it looks like, then it would be I2 is equal to, so this time it's going to be 18 and 16, and then it will be 10 and 2, and denominator is the same as above. So it's going to be 18, 16, minus 16, minus 28. And this will give you 0.5 amp, which is also easy to find by just applying this 1 amp. And then from there, we can figure out that V out is 16 times I1 minus I2, which is 8 volt. Problem solved.